Good morning, dear student. In today's lecture, we will discuss the CHI 334, that is your practical course, in which we discuss the section first. So, in previous lecture, we already discussed one practical, that is analysis, that is the synthesis of acetylferrocene. So, in this lecture, we will discuss the analysis of zinc-chrome pigment. So, what is this pigment? Pigments, it is an important constituent of paints. So, if you consider it is an important constituent of a paints, it gives the paint color and the binding power of a paint. The color of the pigment depends on the transition metal atom. It is insoluble in water, and the analysis can be done by volumetrically and gravimetrically. So, generally, you have to determine the zinc and chromium from the pigment. So, this zinc can be determined volumetrically, and again the chromium, it is also, so you can write analysis is done by volumetrically or gravimetrically. It is not an or gravimetrically, it is also done by volumetrically. So we are very much interested in the analysis of zinc and chromium. So you have to find out the amount of zinc and chromium from this zinc chrome pigments. So let us discuss the procedure, and we will discuss the determination of both zinc and chromium. So if you consider the dissolution procedure, dissolution, you have to take 0.5 gram sample, that is your zinc chrome pigment. You have to dissolve in a 2 normal H2SO4 solution. So if it is not dissolved, then you have to use the concentrated solution. So you have to dissolve the sample into H2SO4 solution and then dilute up to 250 ml. I have to dilute up to 250 ml. So this is very simple procedure of dissolution. You have to take sample of zinc chrome pigment, dissolve in acid and dilute up to 250 ml. So let us discuss the first point, that is determination of chromium by iodometrically. So we are very much familiar with this iodometric technique for determination of metal ion. So iodometrically, iodo means the titration in which the liberated iodine is titrated with Na2H2O3 solution. So we know that whenever there is iodometry, there is a titration with Na2H2O3, that is sodium thiosulfate. So we are very much interested in the determination of chromium by iodometry. So what is the procedure? Before discussing the determination of chromium by iodometrically, so we know that this Na2H2O3, it is a secondary standard. It is a secondary standard substance. So before titration, you have to find out its exact concentration by titrating with primary standard substances such as potassium dichromate. So you have to titrate with this K2Cr2O7 using starch as a indicator. So it is a primary standard. So you should keep in mind, whenever you have to use Na2H2O3, it is a secondary standard. So you have to titrate with primary standard to determine the exact concentration of this Na2H2O3 solution. So this part, it is considered as a standardization of Na2H2O3 using potassium dichromate. So this is the first part, that is the standardization of. Before determination, you have to find out the exact concentration of Na2H2O3, and then the solution, it is used for the main titration for determination of chromium by iodometrically. So let us discuss the procedure for this determination of chromium by iodometrically. So you have to take 25 ml diluted solution which is diluted. Okay, so the sample which is dissolved and the solution is diluted up to 250 ml. So you have to collect 20 ml diluted solution, 20 ml diluted solution in a stopper bottle, and then you have to add 25 ml dilute H2SO4 solution, and then you have to add 25 ml 10% Ki solution. So this is very simple procedure. You have to take diluted solution, add acid solution, and then you have to add 10% Ki solution. Then you have to allow to stand for 5 minutes. Allow to stands for 5 minutes, and then titrate with Na2H2O3 solution. Titrate with Na2H2O3 solution to get pale yellow color. Pale yellow color. So we are very much familiar with this iodometric titration. So you have to take diluted solution, add 10% Ki solution, okay, titrate with Na2H2O3 solution until we get a pale yellow color. Then you have to add starch indicator. Add starch indicator and titrate again with Na2H2O3 solution up to the color, that is the color of the solution is changed from blue to green color. That is, what is the end point? The blue to dark blue color changes to green color. That is your end point. This is your end point of the titration. So it is very simple. So if you consider what is the role of this Ki solution, so we know that whatever the chromium which is present in your solution, it is act as your oxidizing agent. So whenever it is an oxidizing agent, so therefore it will oxidize different compound. So it will oxidize this potassium iodide. So you should remember, that is the conversion of this potassium iodide to iodine. That is, you can write here. So this is the procedure. So let us discuss some important points regarding to this determination. That is, this Ki, potassium iodide. So we can consider only the iodide. This I minus, it is converted into I2. So in which iodine, it having a -1 charge, so and it will convert into I2 in which the iodine having a zero oxidation state, means the oxidation number it is increases, that is -1 to 0. So it undergo oxidation reaction, and this oxidation is carried out by using the chromium present in your solution. So this chromium, it is your oxidizing agent. So this chromium, it will oxidize the iodide into iodine and get reduced, and the liberated iodine, it is titrated. This liberated iodine, it is titrated with Na2H2O3 solution. So you should remember the conversion of iodide into iodine with the help of this chromium, and the iodine which is liberated, it is titrated with Na2H2O3 solution. The amount of iodine which is liberated, it is directly proportional to the amount of chromium present in your solution. So how much iodine which is liberated, it is directly proportional to the amount of chromium present in your solution. Again, we already discussed the procedure. So this is very simple iodometric determination of chromium, that is liberated iodine titrated with Na2H2O3 using starch as a indicator. So let us discuss the second component, that is the zinc. Determination of zinc. For determination of zinc, you have to take 100 ml diluted solution. So we already prepared 250 ml solution, so I have to take 100 ml diluted solution, then I have to neutralize this solution, neutralize with NH4OH using methyl orange as an indicator, using methyl orange as an indicator, using methyl orange as a indicator, and then I have to precipitate zinc as a zinc sulfide using H2S gas. So I have to take diluted solution, neutralize with NH4OH using methyl orange indicator, precipitate zinc as a zinc sulfide using H2S gas, and then dissolve the ZNS precipitate, zinc sulfide precipitate, in hot HCl solution. Hot HCl solution. First you have to wash with hot water and then dissolve the precipitate in hot hydrochloric acid solution, and then dilute up to 100 ml, dilute up to 100 ml. So you have to take the original diluted solution, neutralize with NH4OH, and then precipitate zinc and zinc sulfide using H2S gas, and it dissolve in acid and dilute up to 100 ml. The next procedure is very simple, that is determination of zinc by complexometry using ethylene diamine tetraacetic acid EDTA solution. So I have to collect the solution in 100 ml. So I have to take 10/25 ml diluted solution in conical flask, then you have to add a buffer solution, of pH 10, and I have to add a buffer solution of pH 10, and then I have to add zinc-chrome black tea as an indicator. So this indicator, it is used for titration, that is you have to add EBT as an indicator for this complexometry titration. So it will give wine red color to the solution, and then you have to titrate with standard EDTA solution. So the end point is wine red color changes to blue. So this is your end point. So this is the simple procedure, that is we can determine both chromium and zinc volumetrically. For determination of chromium, they have to use iodometric titration, and for determination of zinc, they have to use complexometric titration. So to maintain the pH of the solution, which is equal to 10, this EBT indicator, then I have to add zinc-chrome black tea indicator and titrate with EDTA solution. Wine red color changes to blue. So, and the calculation is very simple. Okay, you have to take 3 readings. Similarly, you have to take 3 readings, and you have to find out the CBR, constant burette reading, and which is used for calculation, and finally you have to find out the percentage of both zinc and chromium. So you should remember this process for determination of zinc and chromium. In next lecture, we will discuss the another practical, its aim, its procedure, and the determinations. So this is all about the zinc chrome pigment. Thank you.